All right, what's up, AP Stat students? I am coming to you with a new, really short lesson. Hopefully, this is under 5 minutes. It's about probability that you already know how to do. So, we're going to go back in our mind to 8th or 7th grade when we had to do 8th grade math, depending on if you were ahead or not. So, and we talked about the marble problems. So, instead of marbles, I have poker chips. All right, so the probability, I have 3 red poker chips and 2 green poker chips. And so the probability of me pulling 1 red poker chip is common sense. Probability is the number of choices of what I want out of my total. So the probability of randomly selecting 1 red poker chip is 3 out of 5 because I have 3 choices of red and I have a total of 5 that I have to get through. All right, so now the harder part is doing 2 or more than 2. So we want the probability of maybe 2 poker chips or 3 poker chips and certain colors of each. Well, in mathematics, when you have to do the probability of more than one event and you want it to happen concurrently or at the same time, that's AND. So that is multiplication. So we're going to be multiplying fractions here. So let's go back and look at our sample. We have 3 poker chips and 2 green poker chips. So what is the probability of me pulling 2 red poker chips? All right, so let's get our first fraction. Since it's 2 events, we need 2 fractions. So the probability of me pulling my first red poker chip is still 3 out of 5. Okay, now to get the second fraction, I have to pretend that the first event happened. So I'm going to go ahead and get my first poker chip and take it away. It changes the outcome of my next fraction. So I don't have 3 poker chips now. So the probability of getting 3 red poker chips, the probability of getting the second red poker chip is now 2 out of 4 because there are only 2 red poker chips and there's only a 4 total out together. So the probability of pulling 2 red poker chips would be 3 out of 5 times 2 out of 4. So that's our focus for this whole lesson. That if it's a non-independent problem, that your second event is affected by the first event. So here we go. All right, so example number 1, this is actually on your worksheet. You can follow along because you have to finish that worksheet. There are 12 shirts in your closet, 8 blue and 4 green. You randomly select one to wear on Monday and then a different one on Tuesday. Now, the way these questions are worded is weird, but the last sentence is the probability that you're finding. What is the probability that you wear a blue shirt on Monday and a green shirt on Tuesday? All right, so let's talk about our total. Our total is 12 right now. That's our first, that's going to be our denominator. They want us to wear a blue shirt on Monday. That has to happen first. So my first fraction is going to be 8 out of 12. All right, so we need a second fraction. So where is the second fraction going to come from? Well, the probability the next day for Tuesday, I need to get a green shirt. Well, I've already worn the blue shirt, and they didn't tell me to put it back in my closet because it's funky. I need to put it in dirty clothes. So I don't have 12 shirts in my closet anymore. I have 11. So, but the green shirt still remains 4 because I didn't touch the green shirt. So my next fraction is 4 out of 11. I need to multiply because it is an N. I want Monday to be blue and I want green to be Tuesday. So hence this is a multiplication of the 2 events. So next thing, I just need to do the math. And I get 8 out of 33, approximately 0.242. For my people who like to do math by hand, how I can do this is, so everybody who don't want to do the math by hand, ignore what I'm saying and go on to the next slide. So here we go. So I would reduce 8 over 12, well they both have 4 in it, to 2 over 3. And then nothing else can be reduced. I just multiply across. 2 times 4 is 8 and 3 times 11 is 33. That's how we get 8 out of 33. But you don't have to do that. You have a calculator that you use. It's fine. I just always like to show the simplified fraction. All right, here we go. So this one's going to be 7 minutes. I really try to do 5 minutes. A cooler contains 14 bottles of sports drinks. Okay, 7 lemon lime flavor and 7 orange flavor. You randomly grab a bottle and give it to your friend, and then you grab one for yourself. What is the probability you and your friend get both lemon lime? Remember that last question is what they're finding the probability of. So you need a lemon lime for your friend. So there are 7 lemon lime, and it's a total of 14. First fraction is easy, 7 out of 14. Now, when I go in there and give my friend a bottle, I no longer have 14 in the cooler. It has dropped down to 13. I also no longer have 7 lemon lime flavored. It's dropped down to 6. So my next fraction is 6 out of 13. I do my math and I get my answer. So for my people who want to do simplified math, we'll make this 1 over 2 because 7 over 14 is 1/2. Okay. Also, there's a 6 and there's a 2. So I'm going to cancel the 2 and the 6, make it a 3, and it's 3 out of 13. Again, you can do this on the calculator. Do not worry about my simplifying. That's just for my people who like, oh, that's cool. I like to do that. You can put 7 out of 14 times 6 out of 13 on the Inspire calculator, and it will give you 3 out of 13. Or you can multiply these two on any calculator, and it will give you the decimal value. Keep going. Number 3. Now here's number 3. This one's different. You flip a coin and then roll a fair 6-sided die. They have nothing to do with each other. I'm not pulling and changing my denominator. No, the coin has nothing to do with the die. So therefore, they can't affect each other. They're independent of each other. So each fraction is just going to be what it is. So when you flip a coin, whether you get tails or heads, that's 1 out of 2. Very easy fraction. When I roll a fair 6-sided die, and they want it to be on odd, where half the die is even, and the other half is odd. So I'm going to get 3 out of 6, which is also 1/2. And so when I multiply that out, I get 1/4. There you go. Let's do the last one that's independent. You roll a fair 6-sided die twice. So this I'm rolling the die twice. The first roll shows a 2. So what's the probability that the first row shows a 2 and the second row shows a 6? So 2, there's only one chance to get the number 2 on the 6-sided die. That's 1 out of 6. And there's only one chance to get a 6 on a 6-sided die. That's also 1 out of 6. They don't affect each other. Each roll is not going to change. I'm rolling a die, so I roll it once. I have the same chances every time I roll a die. So hence, it's 1 out of 36. This is also an independent problem. Okay, I am finished with this lesson. You have 8 problems that you can try. The answers are already loaded for you. And then when you finish, you can go ahead, if you're happy, you don't have any questions, you can go ahead and do the actual assignment that is on Schoology ready for you to do. So you just can go through. I always start out with the notes first. Hopefully you did that first. So if you have questions, I will have a Zoom meeting. I will send it in Remind if you have questions at probably 1 o'clock. So 1 o'clock, I will open up Zoom if you have any questions. I will talk to you guys soon. I'll see you in the Zoom meeting this afternoon.